All right, I think it is time to start. So welcome everyone to our breakout. This is Lessons from the Greening of Steel. My name is Jen Snook. I'm a manager with the Renewable Energy Buyers Alliance, and I run a program called Decarbonizing Industrial Supply Chain Energy, or DISCE. The DISCE program uses the collective power of large consumers to accelerate the market for low carbon industrial commodities that use carbon-free energy. Our current focus areas are the solar supply chain, aluminum, and building materials. And building materials in particular uses quite a bit of steel. So excited to be here with you all today and discuss this important topic. I will be moderating our panel, and I am joined by Adam Rauwerdink from Boston Metal, where he's a VP of Business Development, Virginia Dundas, Head of Strategic Environment Programs at Ørsted, and Louisa Plotnick, Head of US Program at the Climate Group. I'll let our panelists introduce themselves further as they provide initial remarks, but I'm really excited to have each of them here today as they provide different perspectives on this critical topic. The iron and steel sector accounts for roughly 7 to 9% of global emissions, which is greater than any other single industrial commodity. As such, it's a key decarbonization target if we're going to meet our climate goals. At the same time that we need to aggressively cut emissions from this sector, it is expected to grow. Demand for the material is society-wide, from buildings to transport to even the wind turbines that will fuel our green future, such as those that are produced by Ørsted. So there are multiple levers that will need to be pulled to electrify and decarbonize steel, including new technologies that are in development now. Adam represents one of those companies, Boston Metal, and will speak to the work that they are doing. Steel is one of the hard-to-abate sectors, and as such, is going to take a coordinated effort and a strong demand pool to decarbonize. Steel Zero is one such initiative, and both Virginia and Louisa will speak to the work that they are doing to speed up the transition to net zero steel. With that, I will pass the virtual mic to our speakers, starting with Louisa. We plan to have some time towards the end for questions, so please drop them in the chat as we go. I'll endeavor to share my screen.
Thank you, Jen. It's a pleasure to be here today with you, and I'm not sure where Adam went, and Virginia. Hopefully she gets on board here. And thank you to Verge for spearheading this event. Okay, excellent. So a quick snapshot of the Climate Group for those of you who aren't familiar with our organization. We're an international nonprofit. We're established in 2003. We have headquarters in London. We have offices in New York and New Delhi. And our mission is simple: to drive climate action fast. And we do this by forming powerful networks across our business action campaigns and our Under 2 coalition of states and regions to really unlock the power of collective action towards net zero by 2050. Next slide. So Jen had touched on this. We know that steel is the world's most widely used material. It's in transport, energy, infrastructure, construction, and consumer goods. It's found in almost every aspect of our lives. 50% of the steel is used in construction and infrastructure, 17% in transport, which includes trains and ships, and automobiles, of course. And the steel market is growing in size. It's estimated to be worth about 1.0 trillion by 2025. Next slide. So why steel? Well, we know that steel is essential to our economy, but it also is responsible for 7 to 8% of global emissions. It's a very carbon intensive material to produce. And we know that the technology exists for net zero by steel by 2050, and Adam will talk more about that in his remarks. But what's really needed? We need the rapid deployment of low carbon production technology. We need significant investment supported by the right policy and regulatory environment. And we need this avalanche of what we call demand. Next slide. So we're targeting net zero steel from the demand side of the supply chain. And for this initiative, it's the first of its kind and it has the potential to have significant impact on investment, policy, manufacturing, and production in the sector. While we were developing this program and speaking with multiple stakeholders the year prior before launching, we learned that the push for net zero steel can come from more than just the ultimate buyers of steel. There was great interest from the designers, engineers, and suppliers across the value chain. And in light of this, we expanded kind of that what demand represents, and we created a Steel Zero Construction and Property Working Group. So next slide. Next slide, Jen. So really, what is Steel Zero? We really only have less than 10 years to have global carbon emission. That's why in December of 2020, we launched Steel Zero. It's in partnership with Responsible Steel. It's really a global initiative working with forward-looking organizations to speed up the transition to a responsible net zero steel industry. And there's key components of Steel Zero. There's this community and ecosystem. We're looking to create the go-to platform to develop and collate demand for net zero steel. And an overall objective of Steel Zero is to be the leading platform connecting the growing body of organizations and work related to the decarbonization of the steel sector. We have sector-specific working groups with regular and active stakeholder engagement, and the working groups support companies making progress on their commitment. And then we also have this commitment framework for buyers and specifiers to commit to net zero steel. Next slide, please. So, well, what is the commitment? So basically, to join, organizations must make a public commitment to procure, specify, or stock 100% net zero steel by 2050. And this longer term commitment is supported by an interim 2030 commitment. Next slide. Because we don't want companies to wait. In this commitment, as you can see on the slide here, there's certain criteria to support this, but basically procuring 50% net zero steel by 2030. And there's a different combination of criteria to support that, a combination of responsible purchasing, responsible steel, certified steel, or some equivalent, steel produced by a site that has SBTi targets or some equivalent, and then, you know, the low embodied carbon steel, and we have further definitions for that. So the low embodied carbon steel, it's really specified around emissions intensity, and it takes into account the proportion of end life of scrap. But again, we have some more details on that if you're interested. Next slide. So our members, Steel Zero now has 10 signatories across the construction and buildings industry. And a shout out to our first stakeholder in the renewable energy industry. I'd like to acknowledge Ørsted, who is one of our first signatories to Steel Zero with a 2040 commitment. They're also a founding member of our to-be-launched Renewable Energy Working Group. And as I mentioned earlier, we have a construction and property working group with 20 organizations that are engaged. These organizations haven't necessarily made the commitment, but they're working towards making the commitment. Next slide. So our focus in 2021 is really to expand geographically and increase our membership. We're also looking to launch our Renewable Energy Working Group, which Virginia is engaged and involved with, and she can touch on some more. And we're also looking to launch an automotive working group. And we have our existing construction and property working group where we want to really grow and expand our membership geographically. The current memberships that we have, the 9 members, excuse me, are really primarily focused in Europe, as that's where we initially were targeting and launched. And again, we're expanding globally. And then we're creating this roadmap guidance. And we also want to engage, look how we can engage the public procurement bodies to support this. Next slide. And that's the last of it, Jen. So I guess I'll end with saying we really welcome the opportunity for those of you that are interested to talk through this a bit more as a potential for becoming members or signatories or participating in any of our working groups just to kind of move along the path. So I'll close there and pass the mic back over to Jen. Thanks.
Great, thanks, Virginia. Really helpful framing, and I'm super about Steel Zero, Reba Institute has been working a little bit with y'all, and excited to see where that renewable energy working group goes. Virginia, are you with us?
Hello. Yes,
Hi.
I am,
Great.
but I'm having trouble with my video and we couldn't fix it. So I think it's going to have to be without it, if that's okay.
Okay, no worries. Are you able to share your slides, or should I try to share them?
I think I can do it, but I don't know if it's easier if you do it. I'll try. I'll give it a try.
I think Adam lost power, but he will be rejoining us shortly, hopefully. Hopefully nothing too dramatic happening in the Northeast.
And can you see my slides now?
I do. If you put it in presentation mode, I think we'll be there. Great.
Yes, they're there?
Yep, perfect. Thank you.
Perfect. Hi, everyone, and thanks for inviting me and for the opportunity to speak. My name is Virginia. I'm heading the strategic environment teams in global sustainability in Ørsted. And what I wanted to share with you, and please bear in mind that I wasn't on when you started, Jen, the conversation here. But I think sort of the idea is to share the perspectives of why it is important why decarbonizing steel is important, matters to Ørsted, and matters for decarbonizing the offshore wind supply chain. And to do that, the starting point is to talk about Ørsted's own decarbonization journey. And as a company, we are on track to become a carbon neutral company by 2025. That means in our own energy generation and operations in our own home. And when we do that in 4 years' time, we'll be the first energy company to reach that level. And we will be doing it over 20 years ahead of what climate science says is needed for the energy sector to do it, and to ensure that we can limit climate change to 1.5 degrees. And with that in mind, and with that in mind, what we're doing is we're targeting a net zero across our entire footprint, an entire value chain by 2040. And the key to decarbonizing and to reach a net zero value chain by 2040 is decarbonizing our own supply chain. That is the next frontier in Ørsted, supply chain emissions. And as you can see on this slide, and I'm sharing here, this is because most emissions across the life cycle of an Ørsted offshore wind farm comes from the upstream supply chain. And this is shown by the box that I'm highlighting at the left side of this slide, where you can see that most emissions in our supply chain comes from the materials and the manufacturing that are being used to build offshore wind farm. And they are the wind turbines, the foundations, the cables, and the substations that we are using to build the wind farms. And they're quite heavy to manufacture. They're quite intensive, quite energy intensive to manufacture. And that's why most of the emissions come there. On the second level, and as you can see on the second little sort of column in gray, emissions arise from the transportation and installation of all of these components offshore because of the fuels that are burned by the vessels that do this task. But if we zoom in into the materials and the emissions, approximately 50% of the emissions come from one single material, which is steel. And as steel is mainly used in the foundations that sort of sustain the wind turbines offshore, and they're also partly also used in the turbines themselves. And this is the reason why decarbonizing steel matters for Ørsted and for the renewable energy supply chain. As I think Louisa also touched upon, steel is part of many supply chains and many uses, and it's a big component of the renewable energy value chain as well. And we have a goal that as we accelerate a green energy build out, as we continue to build more green energy out in the world to limit climate change, we want to ensure that it's being done in a sustainable way. And to do that in a sustainable way, we need to also address the emissions that are happening across the entire supply chain and across all of the stages of the life cycle of an Ørsted offshore wind farm, and not only what's happening on our own operations. And that's why we're targeting steel, and we're working with our suppliers with options to decarbonize steel. But then, as I was just telling you, telling you, decarbonized steel is key to reach a net zero supply chain in 2040. And this is not without its challenges. And there are currently 2 levers that we're using to address these challenges. And this is what I wanted to tell you a little bit. And of course, here's where I will touch upon what Louisa was mentioning around Steel Zero. One of the first key challenges that you also can see on my slide here below is that most of emissions are occurring beyond our first tier suppliers. And of course, they are beyond Ørsted's operational control. So that means that we cannot really we don't have an operational financial control over how to reduce those emissions. So what we did is that about a year ago, we launched the Ørsted Supply Chain Decarb Program, which is a program where we are engaging and collaborating with our tier 1 strategic suppliers, making use of steel, with a view to find ways of how we can go about reducing emissions. And one of the things that we are doing around that is we're working with ways of integrating green electricity in the manufacturing processes as a first step for reducing emissions. Second thing that we're doing, as I mentioned to you, most of the emissions around steel, they don't come from our direct suppliers that are sort of building the foundations or the turbines, but they come further upstream from the suppliers that actually make the steel plates that are being used to build all of these components that go into a wind farm. And to do that, where we have visibility and leverage over those steel suppliers, we're also entering into dialogue with them to find ways of working together to reduce emissions. That is a key lever that we're doing, and very critical when we as a company don't really have a direct control over doing that. Challenge, as I mentioned here, is that these emissions are hard to abate because technology exists today to decarbonize steel, but they're not yet widely available at a commercial scale and a cost competitive way. And the key lever that we're using today in Ørsted is that we've been part of founding the initiative Steel Zero. And the reason for this is that we want to work together with other companies in other sectors that make high use of steel, but we also want to work together with the entire industry, renewable energy industry, because this is not only an Ørsted problem, this is a industry problem, to send a market signal a signal to the market that there will be a demand down the line for green steel. And this is, I believe it's a quite important lever to do, and really, really important when we are asking and when we're looking to transform a sector. This was actually one of the key levers that we use in Ørsted's own transformation. About 10 years ago, Ørsted was not the Ørsted that we know today. It was a company with a business model fully dedicated to fossil fuels, to oil and gas. Today, we're the leader offshore wind developer, and we are one of the largest renewable energy companies in the world. And one of the key levers that we use to transform Ørsted from a fossil fuels-based energy company to a company fully dedicated to renewables has been the demand signals that we were seeing at the moment of when we started the transformation. And one of the demand signals was at that time being given by governments mainly in Europe, that we're setting targets to decarbonize their whole energy system, their own energy systems, that we're setting targets to incorporate renewable energy in the grid. We were looking at the EU. We're also setting targets to incorporate green energy in the whole mix. One of the levers that we were beginning to see that kind of said, okay, maybe it is a good time that we start transforming ourselves, because we had some pressure in our bottom line, and because we would see that there was going to be a demand down the line for what we could offer in terms of renewable energy. And that's when we started investing heavily on offshore wind. And we believe that this is also a key thing that we can do for our own suppliers and for our supply chain, to send a demand signal that down the line we will be there to procure green steel, and that today we're there to be part of the journey, the necessary journey of innovation and collaboration that needs to happen to ensure that steel can decarbonize. I will stop there. I wanted to share mainly what are the key levers and what are the key challenges that we see in decarbonizing the Ørsted supply chain, and which very much have to do with steel.
Thank you so much, Virginia. love to dig into that a little bit more in our Q&A. But first, I'm going to give Adam an opportunity to talk a little bit about Boston Metal and what they are doing. And just a reminder for everyone in the virtual audience, feel free to drop any questions in the chat as we go. We'll have some time at the end to discuss.
Well, thank you very much, Jen. Had a very inconvenient power blip there, but I think everything is better now. So as introduced likely at the beginning, I'm Adam Rauwerdink, lead business development at Boston Metal, and we are on the technology side of delivering a future for green steel. So certainly the demand is coming and growing rapidly, on the work that Virginia and Louisa are doing is really seeding that and growing that. That's going to help our customers, the steel makers, be pushed to deliver solutions, and we're hoping to be the technology that they can turn to deliver green steel and deliver that at the millions and billions of ton scale that's needed to change this market. And when we look at the challenge for steel, Louisa likely showed that the scale of it, nearly 2 billion tons of steel made each year. When you try to decarbonize this industry, it's not a 100 or 150-year-old industry like electricity or vehicle transportation. It's a millennia-old technology that's used to produce steel. The idea of taking iron ore out of the ground, mixing that with a source of carbon or coal, and producing molten iron, and alongside of that CO2. And today at 2 billion tons of steel being produced annually, that's on the order of 250,000 Eiffel Towers each year. You get 6, 7, 8% of global CO2 emissions. So to decarbonize this industry, you really got to either treat those CO2 emissions or completely change the formula for production of steel. And that's the approach that Boston Metal is taking. So taking carbon fully out of the equation for the production and replacing with electricity, and preferably clean electricity. The result is the same high quality molten iron that can go downstream into all the end use products at Ørsted or in automotive. But as a byproduct, no CO2 in the process, or no carbon in the process, no CO2 emitted, just oxygen being emitted that's coming out of the ore. So that's the future that Boston Metal is working to deliver. We're doing this just outside of Boston. So that's the opportunity and the real revolution that this can bring. If a steel plant is no longer pouring off clouds of CO2, but pouring off oxygen, you can really rethink and revolutionize a very, very old industry. And in terms of the solutions that the industry is looking to over the coming decades to provide green steel, there's a whole matrix of solutions. One of the best characteristics of steel, it can be molded into a number of thousands of different end products, but it's also so it's magnetic, very easy to recycle. So the recycling rates for steel are very, very high. And that's it. Today in the US, we have some of the greenest steel because we're dominated by recycling and remelting of scrap. And that is one of the earliest solutions, or the quickest solutions, that you're seeing the steel industry turn to, remelting of scrap to bring that steel back into circulation. And you can do that with clean electricity, a very small amount of it, and make green steel today. But that is ultimately limited both through the availability of scrap, how much you have, where it is, and the quality of the scrap. And that's a big component, especially when you talk about lightweighting of electric vehicles or other high-grade steel uses. So over about 1.3 billion tons of steel each year comes from iron ore, new units of steel. And that's where the blast furnace technology sits. So the options will be in the decades ahead with the billion-plus tons of production capacity in the ground. The ultimate goal is to replace that with a non-carbon emitting solution. That's where Boston Metal comes in. In the near term, you're seeing a lot of work on circular forms of carbon, or CCUS, to try to best reduce the emissions from those assets until their useful life is done. But then the really the only energy source that can compete with coal for 2 billion tons of steel is electricity, and that's where the steel industry is turning. We are using electricity directly on iron ore, electrolysis directly on iron ore. There's also a lot of work looking at green hydrogen, using electrolysis to split water, and then using that hydrogen to retrofit some different assets or different technologies to produce steel. So there's a whole matrix of solutions that the steel industry is looking at. They're at different time points in their development, different maturity levels, They have different trade-offs from a cost and feedstock flexibility and production level. But the ultimate goal is that many of the steel makers are pledging by 2050 to be fully carbon neutral. Some of those will be faster. Many of the U.S. steel makers are already very close just because of the high dominance of recycled steel. But there's a lot of work that's happening. And that's the mission we're trying to deliver on, to be able to produce emissions-free steel using our technology. If the renewables prices are attractive, you can do this at a very low production cost and a capital cost. And it's very modular, which opens up a lot more flexibility in terms of how you size plants, how you make capital allocations, and really, where you think about and how you think about the supply chain for steel. And that's gotten the interest when we talk about the supply chain. We look at the group of investors standing behind us. If you're going to revolutionize a very old, very conservative industry like steel, you need good partners. And we're very, very proud of the partners we have. From the steel supply chain upstream, BHP and Vale are two of the biggest iron ore suppliers. So just as Virginia said, the bulk of the emissions from steel aren't necessarily coming from BHP and Vale, but it's their customers using their products. So BHP and Vale are very aggressive in working and investing in solutions that can help decarbonize the production of steel. We're an example of that, to help BHP's and Vale's customer and our customers, the steel makers, have green solutions. You're also seeing end-use demand with BMW as an investor, the pull for green steel in automotive and other solutions. There's also a lot of support from the energy sector with OGCI, PIVA, Energy Impact Partners. So from electric and oil and gas utilities coming together to help drive solutions. And then you certainly need strong financial investors as well. So there's a number of those here. The Bill Gates Fund Breakthrough, the private arm of Fidelity, and others. And that's the mission that we're on. The technology today is based just outside of Boston. In the next year or two, based on a recent round of funding, really scaling this up for continuous production of steel. And then the big commercial milestone that's the next couple of years ahead is the first full-scale pilot in 2024. And because it's a modular technology, if that pilot is successful, you could then replicate, build multiple cells alongside each other, and really see this technology scale in the second half of the decade. And I'm happy to talk more about that as questions come up.
Great, thank you, Adam, and thank you all our panelists. So we're going to jump into a little Q&A. I have a couple to get us started, but I'm also seeing some coming in through the chat. I guess just quickly, Adam, who is your target customer? Are you speaking to the traditional steel producers? And if so, kind of what's the feedback that you're getting?
So as a business model for Boston Metal, we're not going to be a steel maker, not going to be a steel plant builder. So you can think of us, there's some key components that we'll supply, but primarily licensing the technology through some big construction companies. There's 3 big ones that build steel plants. So we're working very closely with them, and we're working and talking very closely on a global basis with the big steel makers. And there's very, very strong interest. There's a lot, some big milestones ahead for us that will really bring those discussions to the next level. But we are talking globally with the steel makers, and it's both integrated steel makers, those that have the blast furnaces today, but also what would be called the mini mills, where they're remelting scrap, because they do need pure units of new iron as well. So the technology is applicable to both, but the big decarbonization benefit comes from ultimately replacing the blast furnace.
Thanks. And I guess in terms of that kind of potential for stranded assets, I guess the ones that cannot be retrofitted and include your new technology. Virginia, curious if you could share a little bit about your perspective, any advice that you would give to steel producers to kind of make that transition, given the history of Ørsted.
Yes, of course, I can do that. I think we see a lot of resemblance between the own journey that we did on transforming Ørsted from a fossil-based energy company to green, that we see that needs to happen in the steel sector. At the moment, there is a need, as Louisa mentioned, steel is being used in different value chains, and there is a need to transform that and to decarbonize steel, to help decarbonize the supply chain and the value chains of many products like renewable energy. And I think that one of the key if I can mention a couple of advices or at least lessons learned from us, it's look at the market signals. Ørsted has made a commitment to procure down the line green steel. There are other sectors that are also doing the same, that other big companies that are also doing the same. Steel Zero is a really good initiative that is trying to bring together that critical mass of companies that are doing that. And that is sort of to say that it should give an incentive for companies, for steelmakers to dare to make that transition. Yes, it's going to be difficult. Yes, it's going to cost, but it's a necessary change to bring long-term resilience and long-term profitability to their business model. And that is something that we're beginning to see down, and it's the main contribution that we're trying to do. That's what we did back then when we started transforming. We have a business model that wasn't profitable, but we began to read the signals that the European Union, different governments in Europe were beginning to set targets and to look at renewable energy. And we said, okay, we had a little bit of a niche. We were the first ones to do and to build an offshore wind farm off the coast of Bonneby, a small town in Denmark. So we have a little bit of knowledge and know-how about something, and then we started sort of tapping into that and saying, what if we transform our business and we start doing something different than this? And we started very slowly but surely and use that market signal demand. So that would be the first thing to do and to say. The second one is to look at, I think, a little bit of what are the key technologies and ways to use. And Adam presented a really good option here today. So look at that, see what are the options. There are many good options to do, and engage with your customers on this. We are trying to engage with our suppliers through the Ørsted Supply Chain Decarbonization Program to work together on this. This is a shared journey. It was the same for us when we started transforming Ørsted. We realized that green energy wasn't cost competitive at the moment. Offshore wind was quite a niche and very, very expensive at the moment. So we worked together with our suppliers to bring down the cost of green electricity. And actually, we were able to do that much faster than we anticipated. We started a program for doing that in 2012. And in 2017, we managed to make green energy cost competitive with fossil fuels in a way. And by 2018, green energy and offshore wind was cheaper than new coal, gas, and natural gas and other fossil-based power energy generation in many parts of the world, in actually 2/3 of the world. So I think that those would be my two advices. Look at the market signals and engage with your customers on how to work together on making sure that there is collaboration around the necessary innovation that needs to happen to make the technologies available at scale.
Thank you. And on that point of collaboration, Louisa, curious to know kind of what Steel Zero sees as the greatest opportunities for collaboration. Oh, you're on mute.
Yeah, for us, I mean, we work with a number of different stakeholders, nonprofit experts like REBA. We work with business associations. We work with the corporates. And for us, it's really looking at bringing together this coordinated voice and the go-to platform to really focus on the steel sector, as we believe this is one of the key levers to drive change in this industry. You know, Virginia's touched on it. Our overarching goal is that, you know, Steel Zero and its committed leading companies will send a powerful demand signal to steel producers, investors, and policymakers to accelerate the transition to wide-scale production of net zero steel. And hopefully, you know, as we really increase our membership, I mean, we launched another flagship program of ours, the RE100, where companies commit to 100% renewable energy globally by 2050. And at the time, people were like, oh, that's not possible. Well, that's not possible. And now we have over 200 members. So really leveraging that collective demand voice of RE100 has been quite powerful for changing policies globally and market transformation. So hopefully, again, we just launched in December. So having this collective voice and collective community to really advocate on behalf of, you know, changing the steel industry from the perspective of net zero targets, if you will. The collaboration is there, and we're expanding our working groups. So for us, collaboration is key, and really engaging with different segments of the market.
Yeah, only 6 months in, and you have 10, was it 9 or 10 core members, and then many more, it seems like, in the working group. So good progress to date, and excited to see where that goes. So I've seen a couple questions come in, I think, for Adam in the chat. One about emissions from iron ore and mining, so further upstream. I don't know if you can speak to that.
Yeah, no, good question. Good question. Yeah, and if you look at the emissions across the board for steel production, certainly the blast furnace, or looking at the incumbent processes, the blast furnace is the dominant source, the overwhelming majority. If you would take that out of the equation, then yeah, you got to look at where the raw materials are coming from. So as I'll give one example for that, there's a project, it's a hydrogen project, but one in Scandinavia where they're both innovating on how the iron is produced. They're also innovating on how they do the mining and how they produce and work with the raw materials. So they're working on both sides of that. For us, one of the advantages of the technology is that it can use a very wide array of different iron ore grades, and it can use them in a fairly unprocessed form. They would call it fines. If you go to a blast furnace, you have to condition the ore, use higher grade ores and condition them into pellets or sinter. You can think of it kind of a mechanical format. So by eliminating a lot of that pre-processing, you're taking away the emission steps. And we have Vale and BHP as investors, and we'll work with them to kind of optimize the upstream processes of how you get the ore from the ground into our process and how to do that most efficiently. The iron ore companies are working on that a lot as well, because though if you look at them, their scope 3 is the biggest emissions for them, the steelmaker emissions. They're also working very aggressively on the scope 1 and the scope 2 that they can directly control in-house, and that will benefit the overall emissions from our process.
Thank you. Yes, it's totally a supply chain problem, up and down. So I think if anyone would like to submit questions, we have another few minutes. Oh, I see one coming in now around priority policies, state or federal, that you see important to decarbonizing this sector. I don't know if anyone feels comfortable taking that.
Say globally, especially Europe is taking the lead in this. When you look at the sectors themselves, cross-border trade and accounting for carbon is a big one. If you're going to make since steel is such a global commodity, you're going to have to find solutions there to control competitiveness if steelmakers are going to make very strong bets on investing in new technologies. So there's a lot of them. The demand is important. The policy is definitely critical as well.
Yeah, and I'll just echo what Adam had mentioned. Sort of there's conversation around border adjustment taxes and what have you. Biden just announced he was exploring this and looking into this as a potential policy intervention. And as more governments and businesses align to net zero, I mean, well, just it's got to happen. And also the carbon pricing, of course, in the different areas globally.
Yep, absolutely. And I think, Virginia, you were speaking earlier about how Ørsted kind of received that initial demand signal from policy.
I can only echo that there is a key role to play for policy, not only demand signals or the private sector role, but also policy to favor the necessary innovation, collaboration, and adjustment that needs to happen in the market. So, yes.
Great. And so I guess a couple more questions I have. Adam, I know you were talking about, ideally, your technology will use clean electricity, and depending obviously upon cost. So just how much, I guess, electricity are we talking? Do we have the resources today? Is it at the price that it needs to be competitive?
Yep. Yeah. Good. That certainly comes down to the work we're doing in-house as well, in terms of improving the technology, the efficiency, the productivity of the technology. But where we're talking publicly about in terms of energy goals, 4 megawatt hours of electricity per ton of steel that's produced. And just to put that in reference, if you look at the incumbent process, the blast furnace, from processing of the ore and sintering and pelletizing, coking ovens, all of that, it's about 5.5 megawatt hours of coal energy. So our process is efficient, but if you're going to talk about 1 billion tons of steel ultimately coming from electricity, the scale's immense there. So it's ultimately going to would require several thousand terawatt hours per year for electricity. So the demand is immense. That's many decades of deployment out. That's a smaller number than it would take to electrify consumer residential transportation, automotive transportation, but it is an immense challenge. We require it very stable. So if you look at how aluminum is produced today, it's using a very similar process. It's essentially a baseload demand for power, and we are the same. So we do need stable power. So energy storage, hydro, all the balancing resources is an important part of the puzzle for technologies like us. And looking $30, $40, $50 per megawatt hour in terms of pricing to really be competitive without a carbon tax. If you're introducing large carbon taxes, that's a different equation. But to compete direct, right around $40 per megawatt hour.
Virginia, I saw you came off muted. Do you have some time in?
No, that's fine. I was just adjusting the volumes.
Great. And so another question on retired assets and asking steelmakers to switch to new processes. I know we spoke a little bit about that before, but curious if there's any more detail.
Yeah. So one of the benefits, one of the options we give, because it's a modular technology, is that you can add in the near term incremental capacity. So that's one way of seeding the market early on. That's ultimately, the ultimate goal is multi-million ton plants being built greenfield using our technology. So I think a natural element of that, and this impacts the demand for electricity as well, is that steel assets are very long life. So there are blast furnaces in the ground with 20 years of productive life left. Do we get to the point where we're taking those offline early to replace them with green solutions? Hopefully, but if not, you're going to see a natural deployment over the next couple of decades as solutions or as existing plants come to their end of life. Are they going to be refurbished, or are they then taken offline? And we think we'll have a competitive solution that can compete. But incremental capacity along the way, new greenfield steel plants that are being built. The population is growing. The use of steel per capita is growing. So the demand for steel is going to continue to grow and be in different regions of the world than maybe it was historically. So there's going to be needs for new plants, plus a natural replacement cycle in the decades ahead.
My understanding is there'll be significant growth in India, which also has a lot of renewable assets, potentially. So Virginia, going back a little bit, I love that image that you shared earlier with kind of your supply chain and different tier suppliers. I was wondering if you could just speak a little bit more about engaging beyond tier one.
Yes, I'm happy to do that. It's always difficult to engage with suppliers directly beyond tier one. We are actually in the lucky situation, but for steel suppliers that also account for the vast majority of emissions, we have visibility and relationships to some of them, the ones that deliver the plates to our foundation suppliers. So we are actually we have them in scope of our program. And what we're doing is that we are discussing with them together the challenges of decarbonizing steel, the avenues there are to pursue, and finding ways of where and how Ørsted can support. And that is something critical that we find in a way for helping the journey. But it's not the only thing, and it's not always the easy one. And that's where we see the value of cross-sector collaboration or industry collaboration in initiatives like Steel Zero. That's where the value really comes in. Because to really sort of influence the supply chain more upstream is not something that we can do directly. We need to work with our direct suppliers that work again with their suppliers and so on. So I think the key important thing is that you have to sort of somehow rely on different levels when you talk about influencing, reducing emissions further upstream in the supply chain. Another key element of that engagement is that we're really targeting there where it really matters to us. So we're really talking with the suppliers that are strategic for us for the pipeline of projects that we have that we're going to be building going forward. So we have taken a really forward-looking approach to how we do the engagement. Usually a lot of companies look at, okay, where do we put a lot of our money? Where have we put a lot of our money over the last 5 years or so? We're actually looking at where and who will be our partners going forward on this journey, and how can we work with them from the very beginning of a development of a project on finding ways of decarbonizing steel. And that is sort of a different thing that we're trying to do also with a view to also sort of influence emissions further upstream in a way. So those are the key things that I can share on that part. It's not an easy thing, and one key thing that I want to say is that when we're doing this, we're working collaboratively within Ørsted to talk to suppliers on this. So it's not the sustainability team or the environment team only talking to them. It's actually we're doing it together with procurement, which own the relationships with our strategic suppliers on this part, and we're trying to sort of do it as part of the whole engagement that Ørsted does with suppliers in a way to make sure that we give them the proper home and the proper sort of frame to the discussions that we're doing. I think that's another key important thing. If there are any other companies out there that are looking to get started with the task, I think it's something that has proven to be really valuable and really useful for us on this journey.
Thank you. I think that is a great point that I think we'll end on, since I think time. The need for collaboration externally, but also internally, is very important. So I want to thank everyone, our panel, Louisa, Adam, and Virginia, for being with us, and everyone who attended today, learning a bit more about this critical issue to decarbonize and electrify steel. Thank you.
Thank you.
Thanks, everyone.